Hello and welcome to the Creation Kit scripting series Papyrus tutorials. This is the 9th part of the events and functions, and we're still in the subsection of recursion. In this episode we're going to talk about helper functions and specifically focus on recursive helper functions. So what are basic helper functions? They're just functions of a similar name to an already existing function, but it has additional arguments. They perform the similar function, but they might do something slightly different. A simple example I gave here, if you have a message that's designed to do a debug message box called print, and you have a string with message, whatever message that you want to give to the message box, and then print integer help. Basically, if you want to add an integer value on, and message, and if you want to add a float value on for the float help. So what are recursive helper functions? They're recursive functions with additional arguments, typically. Or they are functions that have the same number of arguments, but they perform the calculations in a slightly different manner, which we'll see an actual example in the coding and later in the slides. So they execute within the very first function at some point. For example, let's say we have fact of 4, and then we have fact helper, which keeps track of the result from fact of 4, and it reduces the calculation to the fact of 3. And it will keep doing that recursively, so it will have 4 times 3 in the next result, 4 times 3 times 2 in the next, and so on and so forth. So when are helper functions used? They're usually to keep track of results, to reduce calculation stack, which will help on your memory and it will help on your runtime. They will perform specific repetitive functions at specific points. For example, let's say we're doing division of a number and it's a decimal number through subtraction, like we've looked in a few episodes back. You get to the decimal value and behavior becomes really crazy there, and you can't shift the decimal point over because that would be too easy. Instead, you're going to have to do a sub calculation. Also, if you start with a function that doesn't return a value, we'll have an example of this one as well, but it requires a function that does return values on the subsequent calls of it. So let's look at our first example, which is going to use what I just talked about, recursive concatenation of strings. So say you have a message called yo and want to display that in a message box or a message of some sort multiple times and say like yo 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 yo. So you have function which your first argument is the message, the amount is the second argument. In the case that we're going to look at, I'm going to describe it in this way, but there's other ways to do this function that don't require a helper method. So the base case, you don't need to duplicate anything, so you just display the message. If you are in the helper function and you don't need to duplicate anything, you just return the message without concatenating anything. All other cases, in the primary function, you display the message in the message box. Then within that message box call, you will be doing your message concatenated with the helper function. In the helper function, you either return the message if it's the base case, or you can continue the message concatenated with the helper function until you get to the base case. So let's say you call recursive concat with yo and 5. You should get yo, 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 yo. Okay, let's look at our next example. Floating division by subtraction. You follow the same algorithm as integer division. At the A is less than B case, however, instead of just returning 0, you are going to do a new calculation, which is 0, 0.0, because you can't go any further. Instead, you're going to go division tens place, and your B, no, your A value? Yeah, I think it's your A value. The division tens place, it's going to be multiplied by 10, so you can keep on going. You do the same algorithm in the tens place, except instead of adding 1 or 0, you're going to add 0.1 or 0. And then you proceed to the hundredths place if needed, and repeat the same process, except it's 0.01 instead of 0.1 in that case. And for the purpose of this example, we're only going to do the tenths place and the hundredths place for floating division or decimal division. And this ties into our last example, floating multiplication by division. So you're going to follow the exact same algorithm as integer multiplication by additions, where let's say you have like 1.2 and 2.1. You'll add 1.2 to 1.2. But then whenever you, because 2.1, it's going to subtract 2 times there. So 2.1 minus 2, it's going to have a remainder of 0.1. In the cases where you have values between 1 and 0, there might be a better way to do it than what I'm about to explain. This is what I came up with for the purposes of the episode. We're going to turn the decimal problem into a tenths and hundredths place problem. Basically, you multiply the remaining value by 10, and you perform the tenths place division on it. And it will go to hundredths place if need to, and so on and so forth. So, let's get started, since there's going to be a lot to do here, coding-wise. And let's minimize that. So let's look at our recursive helper function. And we have 3 functions here that we need to implement. No arguments, so let's go to here. And let's start on our first function, which is recursive concat. I'm going to put the comments here just to keep process of, or keep this the same. So our inputs, we're going to have the message and times to display. The purpose of this function is to display a message in a message box n number of times. Example, recursive concat of yo, comma 5 is going to return yo, 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 yo. I'm going to put a space there because spaces matter. Let's do string message and then int times to display. Notice we're not going to do a return here. So if times to display is less than 0, or not less than 0, if it is less than 1. So I'm going to look at my cheat sheet just to make sure I'm doing this correct. Okay. It took a lot of work to actually make sure everything worked. So we just want to return message. base case if you don't need to duplicate. No, you don't need to return. You need to do a debug.message box of message, and that's it. And then all other cases, you want to do a debug.message box of message plus, and this is going to be where we do our recursive concat helper, and we give it message, and we give it times to display -1. Okay, so that's it for that function. Once we get the else's and end-ifs in there. Okay, so let's do our next function. Block, that is, for the helper function for the first function here. So it's, again, it's going to be message and times to display. The purpose of this function is to perform recursive concat but return the string to the original function. So start this off with string as the return type function, recursive concat helper string message int times to display. Okay, so our base case so if times to display is less than 1, we're going to return message. In all other cases, so else, we want to return message plus, and then we're going to call recursive concat helper with message, and then we're going to decrease times to display by 1. Okay, and that is it for this function. Let's compare. It's implemented the exact same. So let's make sure this compiles as is. Okay, first function compiles, so it should work in game. We'll find out though in the testing portion. So let's start on our division function, which is going to be the longest. So our inputs, first number to subtract, second number to subtract, and the purpose of this function is to perform decimal division by repeated subtraction to hundredths place precision. Okay. So we want to have this type float function and then float div by subtract, and then we don't want it int, we want floats here for the values. Float num and float divide by. So base case number 1 if divide by is 0, which it shouldn't be, but we want to make sure we don't get an error. We're just going to return 0.0. Base case number 2, if num minus divide by is 0.0, so num minus divide by in case then parentheses, and if that's equal to 0, we want to return 1.0. Base case number 3, which is where the change is going to happen, if num is less than divide by, and it's not 0. Yep, that's correct. Okay. Since this is a complex script, you have to plan them out more ahead. Whenever we get into more complicated scripts in the future, we'll see an associated algorithm document as a reference document. It's like pseudocode, but not real code. Just so we can keep track of A, what the algorithm's supposed to do, and B, just refer to it without looking at the answer here already. Is the other. So float div by subtract tenths of, then we want to mult 10 of num, and we want to have just divide by here. And that's it for that. All other cases, we're just going to do what we would do normally, return, and then it's going to be 1.0 plus float div by subtract of num minus divide by comma there, and we're going to have divide by again. And that's it for the first function. However, we need to start our tenths place and our hundredths place functions. And we will also need a multiply by 10 function. So inputs, first number to subtract again, then second number to subtract. Purpose of this function is to assist in tenths place division by subtraction. So again, we want float function and then float div by subtract. Then we want to call this tenths here, float num, float divide by, we want an end function. Instead of rewriting all this code, which, whoops, forgot the end if there. let's go down here, copy paste that. 0, 0. We want to return 0.1 there, and we want to call this hundredths instead. Down here, we do not want 1.0, we want 0.1. And we want to call this subtract tenths. And that should get it for that function. Okay, so for this last function in the float div by subtract series, we're going to do the hundredths. So first number to subtract, then our second number to subtract. Then the purpose of this function is to assist in hundredths place division by subtraction. Will not go further. So float function, and then float div by subtract of hundredths. Then we want to give it float num again, and float divide by. And just like above, we want to copy paste. Then we want to replace this down here by hundredths. Right here, because we're terminating, we want to just return 0. Right here, we want to do 0.01 because we're doing hundredths place. Right here, we also want to do 0.01 since it's hundredths place. Alright, save that, but we're not done because notice we have a mult10 function that we need to do. So what does mult10 do? So the inputs to this one are going to be the number, and then the purpose of this function is to multiply by addition the input by 10. So this is going to be a float multiplication, and then we want to have float and then num, and then right here all we want to do is return. I'm going to cheat and look at this. So, okay, cool. We just want to return num and then add that to mult10 helper of num, comma, and then 9. Because that's how many times we need to call it again. And for this function, since it's a helper function, we don't have to do it this way, but I decided to do it this way just to get a little bit more of helper function examples in. So we're going to have our number, we're going to have our times to multiply, and then purpose of this function is to assist in multiply by 10. You can use this for any addition here, but we're just going to name it to where it's a helper function of our mult10 function. So we have float num like in the other one. This time we're going to have a times to multiply here. Then our base case, if times to multiply is 1. So if times to multiply is less than 2, we want to return num. Then all other cases, else we want to return num plus, and then we're going to call multen helper again with num, and in this case we're going to reduce times to multiply by 1. Okay. And there's that function. Save here and go back to Creation Kit. Open this guy up. Save. Line 132. That's not the line that's in question, though. I accidentally put a T there. So let's close that. Alright. Y is times to multiply, not defined. At line 132. Oh, that's funny. Oh, because this doesn't have the updated version. Okay. Let's try that again. And boom, there we go. Alright. So let's do multiplication of decimals. So input number to add, and then second number. Purpose of this function is to multiply decimals through repetitive addition. Decimal point values might utilize tenths and hundredths place vision. I'm going to say, first off, there's probably another way to do this that I just didn't think of. But this is how I'm going to do it to show a helper function in a unique way. So let's do our float. Let's see what I called it. Alright. So num to add and num times to add. So our base case, if num times to add is 0.0, so if num times to add is 0.0, num to add, else if, because we need a second case, if num times to add is greater than 0.0 and less than 1.0. We want to return and we're going to treat this exactly like division in this case, so 0.0 plus and then float div by subtract tenths. We're going to pass it. Do you multiply by 10? No, you do not multiply by 10 here, like we do up in the examples above. So num to add, and then this is the mult 10 of num times to add. That should return an accurate result. And then all other cases return num to add plus float mult by addition of num to add, comma, then num times to add minus 1. Let's put an extra set of parentheses just to keep consistent. It would be helpful to have an else here, and we need to end our if block. So let's save, let's go in the creation kit, edit source, see what's going on here. 149. Heh. Heh. Okay. So that should fix that problem. Let's close out. Let's go back here. Save it. And the final step, because we haven't done it yet, uncomment these debug message boxes. We're using 10.1, 2.1 in the first float div by subtract, and we're using 1.2, 0.1. That one, we're using 1.2, 2.1 there, 4.8, 2.1 there. So that's saved. Let's go back here. Edit the source. Save. Okay, everything's saved. Good. Resave. And I will see everybody in game to test those functions out. Alright, we are in game. Let's see if these functions work now. Should start us off with the concat examples. So there we go. We have yo. It's played 6 times, notice. Because it's 0 indexed, how we implement the function. That's alright. It just requires a simple check for less than 2 instead of less than 1. There's the example of just a single yo. Okay, 1.2 divided by 0.1 is 12, so we're good. 4.8 times 2.1 is 10.08, and there's a lot of other decimals after that, but that's all we do here. So that's good. Okay, so 1.2 times 2.1, it is indeed 2.52, if you did it on the calculator, or did it by hand. And then 10.1 divided by 2.1 is indeed 4.8. So that's working. Yeah, all the functions are working. I will see everybody back in the slides for the conclusion of the episode. And we are back. Actually, let me go back to this slide. Notice how long our live coding section was this time. As the problems get more complex that we're going to go into, the episodes are either going to be A, longer, or B, there will be a lot less to present, but a lot more to code and test. So, just want to keep that in mind for the future episodes. So, if you have questions about the content of this episode, scripts in general, past episodes, potential future content, or special topic requests, just anything in general regarding scripting, feel free to message me on the Nexus. I'll have this information in the description of the YouTube video, as well as the supplementary links also there. There will be a little annotation appearing at the bottom. Also, YouTube's a valid way to contact me if you need to with any of those questions or comments or feedback. And I hope to see everybody on the next episode.